Hello guys, welcome to my channel again. We are going to discuss about today that how to communicate between two PLC through open user communication protocol called as T-Send Compact and T-Receive Compact, where we are using the protocol Ethernet TCP IP and we are trying to communicate between two PLCs. I know there are several methods called as put and get methods are also there, but there you are having the limitation of tags. So in this video you can see we are going to communicate between two PLC the whole data blocks, and the data blocks is can be of any quantity. So let's get started with the project. So first of all we need to create two kind of projects, as we don't have the real PLC. Through simulation we will do that. So let's open two kind of projects. First projects, let's give a name called send PLC, and in desktop I will save it. So create it. So our first PLC has been first project has been ready and it is called as send PLC. Let's open with another project. Create new project, and this is called as receive PLC or PLC2 we can give it. So this is one project. Let's minimize it so that both the project will be shown to you. I will divide the screen into two parts. Okay, so let's our first step would be add the PLCs into the projects. So for that, add new device. This process has already been discussed in our very first video. So everyone is, if anybody wants to know how to configure the PLCs, then they can go to our first video, and the link is also in description. So I have added one PLC at PLC2, and we will add another PLC into this project, which is called as send PLC. So in PLC1 project, set the Ethernet address. So here is the important thing. You need these properties and you need to watch carefully these properties so that your process will be very fine, so that you will get the communication between two PLC effortlessly. So first, IP address. In PLC2 we set the IP address as 192.168.0.2, and in by clicking on PLC, in protection and security you will get this property window. In protection and security and connection mechanism, you will get to know the option called permit access with put get communication from remote partner. So you have to tick it. So basically this is the permit you are granting to, or you are giving the permission to the PLC that you can contact or you can communicate with third party PLC or third party device. To do that you have to tick this one. And as we know, need the system memories, which makes job easier. For that, system and clock memory, click on the enable system memory bytes and enable the clock memory bytes. So basically these are the clock signals. These things are also being discussed in our old videos. These are the flickering signals, so that we no need to write a logic for a flickering timer or something. So I have done to this project. I am saving to PLC2 project. Now I will do the same thing for send PLC or the PLC1 project, you can say. So in here the property will be 0.1. This is the second PLC, remember, don't be confused. And again permitted grant on the same method. Some system and clock memory we need in this PLC also. So enable this one. So our configuration part is now over. Now we will go jump into our logic part, or you can say the program part. So first of all, remember, to send or receive we need two data blocks. So let's add it. One data block called as send data block or send db. Okay, and make sure you change the properties of the send dbs. Untick the optimize block access in the attribute window and press OK. And in send, what we will do, send boolean, which data type would be boolean, and send integer, which data type will be integer, and send string. So basically we will handshake with different kind of data types. That's why I am typing these data types. So this is called as string, and one flickering data type we will connect to the PLC so that the true false will be happen. So we will call as send communication bit. Okay, so this will be boolean. After that, just compile the things so that you will get the offset. So this is perfectly fine. Likewise, add another db called as receive db. Okay, again I am repeating the procedures. Receive db, properties, optimize block access, all are fine. Now you get the offset window. Likewise, in send db we have done, we'll copy all the data, because whatever the data we are copying means sending same data we are going to receive. That's why I am doing this thing. This need not to be perfectly match actually, but there is a concept I will discuss you later. So again, send means we are sending some memory bits and we are receiving some memory bit. So receive integer, receive string, and receive communication bit. Remember, don't skip the video so that you will get the proper solution. Now our DB is being created. Now we are going to do the logic part. In main block, what I am doing is, actually we will do both the PLC simultaneously. So in program blocks, you can see in PLC2 there is nothing is being added. So these two function block we will copy, Control C from this project, and in program blocks we will add it so that we need not to do the properties and all the things in the second project. Now go to main windows. In main block, both are in both project, the main block is currently not having any logics. So to do the logic, we will put an empty box and type t send c, which means t send compact, which establish a connection between two TCP address or two open protocols. If we will expand, you can see t send c means establishing a connection and sending a data. So double click on it and enter. So it will ask you for a DB. Let's give a name called tsendcdb or remain as it is. And now in configuration, so we need to expand this window. In configuration, you can see it's asking for the partner. This configuration window will directly open, or you can click on this configuration window so that you will get this. So it will ask you partner. For partner, put unspecified. Please follow the procedure correctly so that you will get the proper solution. And for connection data, make a new. So this DB will create automatically. You can see PLC1 send DB is automatically being created and as well as connected, because we have set the parameter likewise. So active connection establishment, what does it mean? Active connection establishment, when from where the data is being set, that will turn as a master, and the receive PLC will turn as a slave data block. So the active connection establishment, if you are click on here, that means you are making the master for this PLC, and the partner port you are deciding. So whatever your partner port is here, you need to set in your partner PLC also. So we will get to that part later on. For now, remember the connection ID has to be unique. Okay, so in unspecified you can see the partner is unspecified, right? So the partner IP should be here. So what is the partner IP? 192.168.0.2. So if you will remember, we have already set in the partner PLC, so same kind of data will be here. So in data we have already created the send data block. Just drag and drop the data block directly, so that whole data block is connected to the tsend compact logic block currently. So whole data means whatever the data is in the DB will be transferred to another slave PLC or the receive PLC. So send is done. Now we will go for the receive. Likewise, this PLC is sending the data to the another PLC. Likewise, you need to receive. So for that, again, one more thing, you can type on the T receive, or you can go to the extend communication part where you can find the same DB, same function blocks, and open user communication. Here you can see the T receive. See, I'm just dragging and dropping the windows. Again, it will asking for a DB. Remain the name as it is, no problem. Again, it is asking for the partner. So right now we have set T send C. Right now we need to configure the T receive C also. So again, partner is unspecified, and the configuration mode will be remain as it is, called as user program blocks, but the connection data will be new, not send DB, because already is being created. That's why it is showing here. So don't follow that procedure. Press on new. So new means now you will get the PLC1 receive DB. So you can see the connection IDs automatically is being set to 2, because we are using 2 function blocks. So each of the function block need unique connection ID. See in T and C, if you can see, the connection ID is 1. In T receive C, the connection ID is 2. Again, you need to enter your partner port 192.168.0.2. Okay, so in T send C, what we'll need, the send block is execute in pulse basis. So if you will give some tag, so it will only execute once. So we need to refresh the T send tag, T send function block every a particular say clock or something. So we will type as clock 10 hertz. Currently I am typing. So in the function block will be refreshed in 10 hertz speed. So I am putting clock 10 hertz, but in receive you need to put true only, means you are always ready to receive. So whatever the data is being sent from another PLC, it will receive automatically. So only send block needs to be refreshed every time. So in data, connect the receive DB. So now we are all done with PLC 1. So we will do one more thing. I am putting a NO block. If you can see, we have created a tag called send communication. So what is send communication? I will tell you. So this is send communication bit, and I am typing here clock 1 hertz, means one frequency, means one the 1 second flicker, means this boolean send communication bit will be true and false in every second, so that we will get that true and false in the another PLC. So this is being write from clock 1 hertz, and this data type is already is connected to send DB. In send DB you are getting all the types. So you are all done with your first PLC. Now we will go to the second PLC. In second PLC you can see there is nothing there. Again you need the same things. Go to the instruction, minimize all the things except communication, open the open user communication, drag and drop the tsend compact, give a data block name, whatever it is coming, tsend compact. Go to the configuration. In partner, specify unspecified. Here you can see the IP address of current PLC is 192.168.0.2. Likewise, we have done in previous PLC. Give a new connection type. It will give the connection ID automatically 1. Again I am telling you, while it is sending the data to another PLC, the master connection, active connection establishment should be here, not here. But while receiving, the active connection establishment should be here. So first of all, the connection ID is 1, PLC is 1. We will set the partner IP called as 192.168.0.1, and the partner port is 2000. So we have done. And in tsend execute bit, again clock 10 hertz. You can reduce the time whatever you want it, and the data, it would be send dB again. Now T receive compact, in configuration show it unspecified, new, and the unique ID is 2 right now, and the dB is PLC1 receive dB. But here the active connection is at remote side. Why? Because we are receiving, the send should be active connection establishment, and our local port has to be defined as 2000, as we are set the local port 2000 in our second project. If you will see in second project, what is the configuration, you can see 192.168.0.2, but for receive we have done a mistake. For receive we need to check here active connection establishment. So local port is 2000, we have sent it. Okay, so our local port means what, we are receiving the signal at our PLC port number 2000. So that you need to set the, in send block you need to set the partner port. In partner port you can see 2000. So the partner port and the other project's local port has to be same, otherwise your PLC communication will not be done. So in this project we remain with our send dB, we are connecting the dB. Likewise we have done with another project, we are doing this. So T send dB is now okay. This is our T receive C, we have connected the wrong dB. So I am connecting the correct dB, and in configuration everything seems to be okay except the IP address 192.168.0.1. so we have set the IP address as well. So now likewise in first we will send a flickering or pulse bit to our another PLC. So send communication bit, and this is called as clock. We will overview the project again because the data is being repeated twicely or tertiary times, so you are getting confused. So we are ready with our projects. So you can see we are having currently 2 projects. So here is the PLC2, here is the PLC1. This project is PLC2 and this is PLC1. So you will go one by one. So we have created receive dB, send dB at PLC PLC1, and receive and send dB at PLC2. So now you can see whatever the data are at the send dB of the project 1, in receive dB we are having the same data, like send boolean, receive boolean, send integer, receive integer. So whatever the data is here, that will reflect on this window, and whatever the data in the second PLC's dB, it will receive at the first PLC's receive. Okay, so everything is okay. Now let's go to the simulate thing. Okay, first we will do for the first PLC. Okay, the simulation thing is already being discussed in our very first video. So if anybody is having any kind of problem, then you can go to that video so that you will get a proper simulation window. So we have done with first PLC. Now it's time to run the second PLC. So both of the PLC is being simulated already. That means currently we are having two PLC and both should be now communication successfully. Let's see if we are getting the data or not. Now let's go to our send DB of PLC1. In send DB of PLC1 you can see, if we will go to online, this is send, and in other this is receive. So we will send the data from PLC1 so that we can get the data at PLC2. So you can see we are not having the communication right now. So here you can see 7005 receive is here already. Sorry, in receive function block, let's see what is the error. It's continuously 7004. If you can see in help window, you can see what does the 7004 means. So error code 7004 means communication has been established and is being monitored, but no receive jug process is in active. So it's showing that okay, we have forgot to do the true bit here. That's we are getting the error. We didn't enable that function block, that's why we are getting the error. Sorry guys. Now you can see the error code is the status is converted to 7006. That means we are receiving the data right now. See. So now we are done. We are sending the data from here. Let's minimize it. So this is PLC1 and PLC2. Let's type a string called as RKB automation, enter. So you will receive string at PLC2, and in receive integer also we will type like 12. By typing here we will receive the data here. See, you are getting the received data. In boolean also, if we will true, then it will true. If we will false, then in PLC2 false. So this is send PLC and this is PLC2. Likewise, now we will send the data from PLC2 and we will receive the data at PLC1. So again, go to the PLC programming, open the send data block, and here you need to open the receive data block. Okay. So the status bit is already being executed, like this is the communication, or you can see the heartbeat of the PLC1, PLC2 is being monitored at PLC1. So this is already working. So let's send some data called as ABCD, let's say. So you are receiving at the first PLC as ABCD, and in send integer, let's type some integer value called as 98. You will get the 98, and if you will turn on the boolean true, it will true, and by false it will false. So in this video, let's conclude this video that both of the PLC communication is being executed properly. There are several methods of doing PLC communication between two make which is called as one method is called as put and get block, but there you will limit it to 10 to 15 tags only. But here you can see the whole data block can be transferred to another PLCs of data block directly. If you are having same kind of property, there is no need to be name need to be same, but the data type has to be same and the order of the data type has to be same. Like you are having boolean here, then you have to have the boolean here. Like you are having integer here, then you have to have the integer here. The place should not be changed, and the data block has to be have the offset value. For that, you know what to do. Go to the properties and untick the optimize block access so that you will get the offset value. So these are the basic things. So two to three things are there. First thing, you need to have the device settings, and on device setting you need to permit the PLC, or you can say put and get block to both of the PLC so that you will get the communication. Second thing, data block has to be in properties. The data block has to be optimized block access has to be on tick. And third point, both of the PLC has to be in the same network. That means the 192.168.0.1 and 192.168.0.2 both are need to be in the same network, so that you will get the communication. So this is it for the today. Let's wrap it off. And if you are having any doubt regarding this video, then please mention in the comment so that I will clear the things. So thank you, and subscribe to my channel if you want this kind of videos, and let me know what kind of video you want in my channel. So thank you.